Good evening, and welcome to The Resting Researcher. Tonight, we're diving beneath the surface of the ocean to explore one of Earth's most mysterious realms, a place where sunlight fades into perpetual dusk, where creatures create their own starlight, and where the rules of survival are unlike anywhere else on the planet. This is the twilight zone of the ocean, the mesopelagic layer, a band of water stretching from 200 to 1,000 meters deep, where day and night blur into something else entirely. Before we begin our descent, I'd love to know where you're listening from tonight and what time it is in your corner of the world. And if you find this kind of gentle science exploration helpful for unwinding, please consider liking this video and subscribing to the channel. Your support allows us to keep creating these calm journeys through the natural world. I hope tonight's expedition doesn't keep you too awake with curiosity. But if it does, at least you'll drift off knowing a little more about the hidden ocean that covers most of our planet, yet remains more mysterious than the surface of Mars. So, settle in, get comfortable, and let's begin our slow descent into the blue. Imagine standing at the edge of the ocean on a clear day. The water stretches to the horizon, sparkling blue and inviting. But beneath that shimmering surface lies a world of layers, each one darker and stranger than the last. The top 200 meters, the sunlight zone, is where most ocean life congregates. Here, light penetrates with enough strength for photosynthesis. Phytoplankton drift in vast invisible gardens. Fish schools glitter like silver coins. It's the ocean we know from postcards. But now we begin to sink below that familiar world. At about 50 meters down, the first change becomes noticeable. The light shifts. The brilliant whites and yellows of surface sunlight fade first, absorbed by the water itself. What remains is blue, a deepening azure that seems to come from everywhere and nowhere at once. Red light disappears entirely within the first few meters. Orange fades next, then yellow, until only blue and violet remain, painting everything in shades of twilight. By 100 meters, you'd notice the temperature dropping. The water here is cooler, more still. Surface waves no longer reach this depth. You're entering the thermocline, a boundary layer where temperature plunges rapidly. This invisible barrier acts like a ceiling for some creatures and a floor for others. Warm water fish rarely venture below it. It's a frontier drawn not by rock, but by temperature. At 150 meters, the blue deepens to indigo. Shadows soften until there are no shadows at all, just gradients of dimness. Photosynthesis becomes impossible here. What remains are the animals, the hunters, the drifters, and the light makers. By 200 meters, you cross into the mesopelagic zone, the Twilight Ocean. Above, the surface is still faintly visible as a shimmering ceiling. Below, darkness waits. Here, life has adapted in extraordinary ways. This zone is home to more fish biomass than all surface waters combined. Yet it remains largely invisible, hidden by depth and darkness. As you continue sinking, the light continues to fade. At 300 meters, it's no brighter than a moonlit night. Your eyes would strain to see anything clearly. At 400 meters, the light is dimmer still, like standing in a forest at dusk. This is where many creatures begin their nightly migration, the largest movement of biomass on Earth. By 500 meters, the blue has turned to black. Only the faintest traces of surface light penetrate this deep. For most purposes, this is the edge of the visible world. Yet even here, the ocean is not truly black, because all around you, invisible until your eyes adjust, are tiny points of light. Blue-green sparks that flash and fade like distant stars. This is bioluminescence, and it changes everything about this dark world. Consider the pressure building around us. At 200 meters, pressure is about 20 times sea level. By 500 meters, it's 50 times greater. By 1,000 meters, at the bottom of the twilight zone, the pressure will be crushing. For creatures born here, this pressure is normal. Their bodies are mostly water, which doesn't compress. But for us, it's humbling to realize how alien this environment is. And yet life thrives here, not despite the darkness and pressure, but because of it. The Twilight Zone offers refuge from surface predators and access to food drifting down from above. As we settle at around 400 meters, hovering in permanent dusk, let your eyes adjust. Let the darkness become familiar, and watch as the first lights begin to appear. In the Twilight Zone, light is currency. Not light from the sun, that's too weak, but light created by life itself, bioluminescence. It's one of the most widespread adaptations in the deep ocean. Up to 90% of creatures here can produce light in some form. Some glow constantly, others flash on command. The chemistry is surprisingly elegant. It requires just two ingredients, luciferin and luciferase. When they react with oxygen, they release energy as photons instead of heat. It's one of the most efficient light sources in nature. Most species emit blue or blue-green light, wavelengths that travel farthest through seawater. But some, like the dragonfish, produce red light, nearly invisible to other creatures. It's biological night vision, allowing them to hunt unseen. Let's meet some of the Twilight Zone's light artists. First, the lanternfish. Small, silvery, with large eyes, lanternfish are the most abundant vertebrates on Earth. Billions fill this zone, their bodies studded with photophores, light-producing organs, arranged like strings of pearls. Each species has a unique pattern, like a barcode of bioluminescence. This helps them recognize their own kind, find mates, and school together. From below, their belly lights create camouflage called counter-illumination. By matching the faint light from above, they erase their silhouette. During the day, lanternfish rest in the deep twilight. But as the sun sets, something remarkable happens. They begin to rise, hundreds of meters upward toward the surface, following the fading light. This is the dual vertical migration. Every night, they ascend to feed on plankton-rich surface waters. Every morning, they descend back to safety. This journey, repeated by millions of fish, represents Earth's largest animal migration. Not across distance, but through depth. There's also the hatchetfish, so thin it looks like silver foil with eyes. Its body is compressed laterally, almost two-dimensional. Like lanternfish, it has belly photophores that adjust in real time as it moves through different depths. Then the viperfish, a predator with needle-like teeth. A glowing lure extends from its back, dangling bioluminescent bait. Its jaw can unhinge to swallow prey nearly as large as itself. In an environment where meals are unpredictable, this ability is invaluable. Perhaps most alien is the dragonfish, slender and black, producing both blue and red light. Most deep-sea animals can't see red wavelengths, but the dragonfish has retained red-sensitive vision, giving it a secret advantage. It illuminates the world in a color only it can see. But bioluminescence isn't just for hunting. Some creatures use light for defense. The vampire squid, despite its ominous name, is gentle, feeding on drifting particles. When threatened, it turns itself inside out, exposing webbing covered in flashing photophores. These lights pulse in disorienting patterns, confusing predators while the squid escapes. A living strobe light. Other creatures eject clouds of bioluminescent mucus when attacked, glowing decoys that drift like false targets while the real animal slips away. The deep-sea version of a smoke bomb. Even jellies use bioluminescence with sophistication. The Atolla jellyfish produces a spectacular distress signal. When threatened, it emits a rotating pinwheel of blue light, flashing in circular patterns. This burglar alarm may attract larger predators to attack its attacker. As you float here, surrounded by these living constellations, it feels like you've left Earth. The rules are different. Light doesn't come from above. It comes from within. Every flash of light is a risk. It might attract prey, but also reveals position. Nothing is wasted. Every photon serves a purpose. But there's another source of illumination down here, besides bioluminescence. Remember that faint blue glow when we first entered this zone? That's not just residual sunlight. It's something more complex. Light itself transforms in this frontier between day and night. Light, when it enters water, begins a journey of transformation. Water is selective about which wavelengths pass through. Red disappears first, then orange, then yellow. By 10 meters, the spectrum has narrowed dramatically. This selective absorption is why underwater photos look so blue. The ocean is literally removing colors until only blue remains. But even blue has limits. By 200 meters, only 4% of surface light remains. By 500 meters, it's 0.01%. By 3,000 meters, the amount is so small that calling it darkness understates it. Yet that tiny fraction still matters. Many Twilight Zone creatures have enormous eyes to detect even a handful of photons. Their eyes are tubular, like telescopes, pointed upward, scanning for prey silhouettes against that barely lighter ceiling. The barrel-eye fish has one of the strangest visual systems. Its eyes are literally tubes, housed inside a transparent dome on its head. Through this clear shield, you can see green-tinted eyes pointing straight up. For years, scientists thought it could only look up. But the fish can rotate its eyes forward when hunting. Many twilight fish have tubular eyes, each solving the same problem: how to see when there's almost nothing to see. Light here isn't just about intensity, it's about direction. On land, light scatters, creating surfaces, shadows, textures. In the deep ocean, there are no surfaces to reflect light. The faint illumination from above is diffuse and directionless. This is why many creatures are dark-colored or transparent. There's no point in camouflage patterns. Instead, survival depends on not being a silhouette. Transparent creatures, like certain jellyfish and squid, take this strategy to extremes. Their bodies allow light to pass through with minimal scattering. It's not true invisibility, but in dim twilight, it's close enough. Others go the opposite route. Black dragonfish and viperfish coat themselves in the darkest pigments possible, absorbing nearly all light. In a world where every photon is precious, being black is like being a void. The physics also affects movement. In water, objects appear less distinct the farther away they are, not from size, but from scattered light filling the space between. This veiling light acts like natural fog. For predators, this means getting close to strike. For prey, staying still can make them nearly undetectable. The Twilight Zone is a realm of ambush and patience. During the day, more light filters down. At night, even that faint trickle disappears. Creatures here experience deep sea day and night, not through temperature, but through barely perceptible light changes. This subtle shift triggers the vertical migration we mentioned earlier. As surface darkens, the risk of being seen decreases and fish rise toward food-rich waters. As dawn approaches, they flee back to the deep. It's a dance choreographed by photons. Now, let's turn our attention to something fundamental: the matter that drifts constantly downward through this zone, because those bioluminescent creatures need energy to glow. And that energy comes from above, arriving as gentle, endless snow. If you could illuminate every particle around you, you'd see something astonishing. The ocean is full of falling matter. Tiny white flecks and filaments drift slowly downward, like snow in a silent blizzard. This is marine snow. It's the primary food source for most Twilight Zone creatures. Marine snow consists of many things: dead plankton, waste from surface animals, fragments of larger creatures, mucus from filter feeders, organic matter bound by bacteria, even dust from continents. Each particle is small, often microscopic, but collectively marine snow represents a massive transfer of energy from sunlit surface to dark depths. Billions of tons of organic carbon sink through the ocean every year. For twilight creatures, marine snow is sustenance that requires no hunting. It falls constantly day and night. You simply position yourself and wait. Many species are efficient particle feeders, filtering water or swimming with mouths open, sieving out organic flakes. It's low-energy living, perfect for a low-energy environment. Marine snow doesn't fall uniformly. It clumps and aggregates, forming patches of higher concentration. Experienced predators position themselves in these invisible buffet lines. Fall speed depends on size and density. Small particles drift slowly, taking weeks to reach the seafloor. Larger clumps sink faster. Fastest of all are carcasses of large animals, whales, sharks, which plummet like stones. These whale falls create temporary oases of abundance. Entire ecosystems colonize them. A single whale carcass can sustain deep-sea life for decades. But in the Twilight Zone, most creatures depend on steady marine snow accumulation. The giant larvacean builds a mucus house around itself, sometimes a meter across, that acts as a filter, trapping marine snow. When the house clogs, the creature abandons it and builds a new one. The discarded house sinks rapidly, becoming its own form of marine snow. Copepods, tiny crustaceans, fill the ocean in unimaginable numbers. Many are filter feeders, creating currents to draw in particles. They transform microscopic matter into larger packages that fish and squid can consume. At night, copepods rise to feed on surface phytoplankton. During descent, they digest and excrete waste, contributing to marine snow. It's a biological pump, moving carbon from surface to deep. This process is one of the ocean's most important roles in regulating Earth's climate. By transporting carbon from the atmosphere to the deep sea, the ocean removes billions of tons of carbon annually. The Twilight Zone is the engine of this pump. Creatures here determine how much carbon reaches the deep floor and how much returns as CO2. The food web here is not a simple ladder, but a tangled network. Predators are also prey. Scavengers become meals. Even the dead continue feeding the living. Jellies are effective predators, their tentacles like living nets, capturing copepods and fish larvae. When jellies die, they become concentrated organic packages. As they fall, fish and crustaceans pick at them. Siphonophores, colonial organisms stretching tens of meters, form living curtains of stinging tentacles. They drift passively, waiting for prey to blunder into their traps. Despite their size, they're fragile. But in the still twilight, they thrive. Every ecosystem layer depends on the layer above. Surface phytoplankton captures sunlight. Zooplankton eat them. Small fish eat zooplankton. Larger predators eat small fish. At every step, waste and death feed scavengers and recyclers. It's efficient and resilient. Energy flows downward. Nutrients recycle upward. Driven by daily migration, and the slow fall of marine snow. As we hover here, surrounded by invisible falling particles, remember how connected these systems are. The carbon you exhale becomes atmospheric CO2. The ocean absorbs it. Phytoplankton use it to grow. Zooplankton consume them. Some of that carbon ends up here, drifting slowly toward the abyss. In a real sense, your morning breath might one day fall through this water as marine snow, feeding creatures you'll never see. In the darkness of the twilight zone, where light fades to almost nothing, sound becomes more than noise. It becomes language, a map, a way of sensing the invisible. Unlike light, sound travels beautifully through water, faster, farther, with less distortion than in air. A whale's call can travel hundreds of kilometers, bending through temperature layers, but always carrying its message. Creatures here rely on sound in ways we're beginning to understand. They click, buzz, and hum, creating acoustic signals that reflect off prey and predators. It's echolocation adapted for the deep. This soundscape, invisible but rich with information, forms another dimension of the twilight zone, one that doesn't rely on photons, but on vibrations through water. As we end our descent and prepare to return to the surface, picture the soft clicks of foraging fish, the low hum of passing currents, the faint, distant whale song echoing through the deep. The twilight zone is not silent. It's full of whispers, conversations we can't hear, but that shape countless lives every moment. As we slowly ascend toward light, let's carry this with us. Beneath the familiar ocean surface lies an entire world, a realm of living stars, falling snow, and creatures adapted to conditions we can barely imagine. The twilight zone is one of Earth's last great frontiers, less explored than the moon, less understood than distant planets. Yet it's here, covering most of our world, quiet and patient and full of life. Thank you for joining this journey into the blue. I hope it gave you wonder, calm, and appreciation for the hidden ocean surrounding us. As you drift to sleep tonight, remember that beneath the waves, in deep twilight, life continues its ancient dance, glowing, falling, feeding, whispering, and in its own way, dreaming. Sleep well,